Complex numbers. I wanted to talk about complex numbers today because they're fascinating. I mean, we wouldn't be able to share media using digital devices without all of the work done by electrical engineers, which is certainly probably one of the strongest applications of complex numbers, though physicists like them too. And part of why I think complex numbers are valuable when you're thinking about this weird algebra form stuff is that in the development of mathematical history, for a long time, this whole square root of -1 thing was just considered weird. People didn't like it. It's why people originally coined the phrase imaginary numbers, even though there isn't necessarily anything imaginary about them. Just for reminders, in the context of what we've done so far, -1 is represented using this character, taken from the laws of form. And complex numbers are important because they're required for closed algebra. So when you're using even simple things like a quadratic equation, the values you can get are often complex. And so it's pretty key to have some kind of way of representing these numbers. And in math and physics, they tend to use I. Electrical engineers tend to use J because they've got other current is I in the various forms. So I think we'll kind of roll with what the electrical engineers are using and use a J that looks sort of like this. In that sense, then, two of these, or J squared, is equal to -1. And what's interesting about this form, if you're using this for your -1, is that then you have kind of a new interpretation of -1 squared, right? So if you think about the physical inversion of the shape as representing sort of the rotation captured by the complex plane, right? If you start with something like this for identity, then you end up having forms like this for your complex rotations. So, and you can think about it as, rotating in the plane. So multiply by I, multiplied by J. J squared is -1, then you have -J, and so forth. So, and obviously order doesn't matter, things commute here, but you can see in the complex plane, it sort of gives you a simple representation too. You can know which one's around which quadrant. And so, reminder, I talked a little bit last time about, or time before, about this relationship here between square and triangle numbers. And normally people only think about these in terms of integers, right? So you can think about this with +1 or -1, and obviously that relationship holds, but it holds with complex numbers as well. So J squared is -1, and then the question is like, well, where do you get with these triangular numbers in a complex space? So these triangle numbers can be represented this way. If you actually go ahead and put in J into the triangle function up or down, you will get -1/2 plus or minus 1/2 J. And so if you switch and use -J, you will sort of switch signs up, switch triangle forms. Right, so if this is your complex plane, these points would be here and here. And so something that's kind of fun and some people will hate, but if you think about these triangle forms, we've been thinking about this in terms of multiplication. So, multiplying by, or operating by 2x's is basically the same as operating by x squared. But you can imagine that there's sort of an analog for addition, and this is, some people will say this is stupid, why do you care, this isn't different than anything else, and you may be right. But I think it's interesting that, right, so where you have this sort of hierarchy of forms for numbers greater than 1, you'll always have these as points on your number line somewhere. And you can think about it sort of an additive form of these, and this may not be the best way to represent it, but if you have x plus x in a square is like 2x, plus x in an up triangle is like 3/2 x, and then down triangle would be like 1/2 x, and So just like for multiplicative forms, this holds. If you replace x with plus x, this form holds as well. And that's kind of cute within the context of complex numbers because e to the I pi over 2, right, is another representation of I. And then e to the pi I is another representation of -1. E to the 3 pi I over 2 would be a representation for -1, and then e to the 0 or e to the 2 pi would be ways of representing 1 itself. So it's just kind of an interesting way that it works within these forms. And obviously if you use -I rather than I, these triangles will swap places, but otherwise you get something fairly similar. So hopefully this gives you some idea of what happens when you start applying complex numbers to these forms of square and triangular number.